Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we are going over section 5.6, Direct Variation. Now, direct variation is a special way to graph a line. It is a line where your y-intercept and your x-intercept are both at the same location, 0, 0. So let's start with our definition. Direct variation is a special type of linear relationship that can be written in the form of y is equal to kx. So a line written as y is equal to kx, where k is the constant of variation. So the constant of variation is our k value. Our line is written as y is equal to kx, meaning that pretty much all we have to worry about is slope. This is the most basic form of drawing a line. We have slope, and that's it. That's it. Yeah, that's it. Just slope. Nothing else. Just slope. Just the slope. So let's look at what this would look like if we were trying to do this in slope-intercept form, or y is equal to kx form. Let's say that we're given the formula y is equal to 2x. To graph y is equal to 2x, the first thing that you need to do is draw an axis. And for those of you who have done this many, many times before, well, guess what? You get to do it many, many times more until you have it down perfect. Our starting point will always be at the origin, 0, 0. That's why it's called the origin, because that's where you originate at. And then from there, we use our slope. Our slope is still rise over run. So we would rise 2, 1, 2, and then run 1, 1. Rise 2, run 1. Rise 2, run 1. Run away, or drop 2, retreat 1. Drop 2, retreat 1, etc., etc., etc. And there you have it, your first direct variation line. Also, the constant of variation can be rewritten as y over x. This is used on occasion, rarely, but it can be used for an example. If you were looking at the direct variation, or write the equation, my pen will be nice to me, write the equation of direct variation through 4, 8. Well, to write the equation of direct variation through 4, 8, we need to know our constant of variation. Well, our constant of variation is really easy, y over x. What's our y value? 8. Okay. What's our x value? 4. What's 8 divided by 4? 2. Awesome. So the formula for this direct variation would be y is equal to 2x. Looks familiar? Coincidence? So let's look at some other direct variation cases. For an example, let's say that we are given the direct variation case of y is equal to negative 1/2 x. Well, to graph this one, first you draw a set of axes. Second, you make your origin spot. and third its slope. Because it's negative, that means I go down. So I'm going down 1 and to the right 2. So down 1, run 2. Down 1, run 2. Down 1, run 2. Up 1, retreat 2. Up 1, retreat 2. And that gives us our beautiful direct variation line. What about the direct variation where we're given a point? Let's say that we are given the point 3, 18. And we're supposed to draw the graph of this direct variation. Well, first we need our constant of variation. Our constant of variation is y over x. For this particular case, it is 18 over 3, which is 18 divided by 3, which is 6. So, judging from that, I think this is going to be a really steep graph. We start at our origin, 0, 0. We rise 6, run 1. 1, 2, 3, 4, 5, 6, run 1. And I think that's about as much as we can get from this graph. Unless, of course, we change the scaling on it, but that's for another time. So, direct variation from a point. Hopefully you get the point. Why is direct variation useful? Well, it's useful in things like selling lemonade. Sorry, I think there's supposed to be an E on the end. Selling lemonade. Let's say that a gentleman sells lemonade. And he made a little chart for how much lemonade he sold and how much money was in his box. We are going to neglect the starting costs of each. And he noted that when he sold 4 lemonades, he got 16 cents. When he sold 10 lemonades, he got 40 cents. And when he sold 50 lemonades, he got $2. First question, is this direct variation? If so, what's the formula? Well, to figure out the formula, that's really easy. Well, actually, both cases are really easy. If all cases of y over x are the same, then it is direct variation. If there was a plus something to it, if there was a shift of the graph, either vertically or horizontally, then our direct variation number would change over time. So, note, if y over x is the same for all points on the graph, then it is direct variation. So given that we have the number of things sold would probably be our x, our profit would probably be our y, let's look at y over x. 16 over 4, well, that's equal to 4. 40 over 10, that's equal to 4. 200 over 50, that's equal to 4. So is this direct variation? The answer to that question is yes. It is direct variation. What's the formula? I think we found out what the constant of variation is. So our formula would be a whopping y is equal to 4x. Super easy, no problems. Should be easy to do, should be easy to follow, should be easily done before you leave my classroom today. So it's the before you go time. So before you go, this is going to be section 5.6, numbers 1 through 9, 11, 13, 15, 17, 21, 25, 27, 33, 35, and 39. I know it looks like a lot, but believe it or not, these are super easy, so you should have absolutely no problems getting through all of them before you leave today. Please note that you should probably keep your textbook at your desk at the start instead of wasting time getting up and walking across the room, because homework is going to be, before you go work, is still going to be due before you leave my classroom. Try to be as efficient as you can. Raise your hand if you have questions. Otherwise, good luck and have fun.